Hi, my name is Deven Patel, and for my EECS final project, I created a sleep quality monitor. The monitor senses the environment for the temperature, light, and sound to assess the quality of sleep. The project was created to help focus the UN Sustainability Development Goals for number 3 and 4. However, this video will focus more on how the system works rather than discussing about the goals and its impacts. So this is the system. Of course, there's a growth kit, there's a temperature sensor, there's a light, sound sensor, LED, buzzer, and the kill switch button. I am using 2 wires. One is connected to the temperature sensor because, of course, this is an external temperature sensor. The temperature sensor embedded into the growth kit is not really good. This one that is outside is more sensitive and it picks up better degrees in the environment. The second wire I'm using goes to the button. It is connected to the AD6. I'm only using this because before the button wasn't detected without the wire, and now I'm using a wire just so that it actually works. The LED, buzzer, light sensor, and sound sensor are not using wires because they're all embedded into the growth kit, and that works much better than having a lot of wires everywhere. I have the code right here. This is my main code. I have 3 functions real quick. Calculate sleep score, classify sleep condition, process sensor data, and the sleep monitor. I also have the 3 unit tests right here. But now I'm going to start the sleep monitor. It's going to say sleep quality monitor in the command window. It's going to connect to the Arduino using a USB-C cable. This is the graph that shows up. In a couple of seconds, it will update. There you go. It updated for the temperature versus time, light level versus time, and sound level versus time. I'm going to close that for a second. Now in the table down here, we have time, temperature, light, sound, and score, status, recommendation. Right now our status is fair, and our recommendation is check temperature, light, and noise level. What we're going to do first to change the state is take the light sensor, and we're going to flash a little light into it. So there's a light sensor. We're going to flash a light into it, and now we're getting a different value. So right now you hear a beep. That is the buzzer and the LED. Whenever the score is below 50, the buzzer will go off as well as the LED. When the score is above 50 but below 70, only the LED will show. What we're going to do to change the state one more time is we're going to take the temperature sensor and we're going to put in our palm to change the sensor. And now the temperature is going higher and higher, changing this potentially the state. But in order for that to happen is for the score to also go high. Right now what I'm going to do is I'm going to take the temperature sensor. I have a cup of ice right here. I'm going to put it right next to the ice so that it goes lower the temperature, and lower temperature means that it's a better condition of sleeping. So you can see that the condition goes higher. So see, it went to good, and potentially it will go to excellent. And there we go, we got excellent. So this is the most optimal sleeping condition. The best one is of course 95 to 100. To summarize the state transitions, an excellent state would be given whenever the score is higher than 85 with no alerts. A good state would be whenever the score is between 70 to 84, giving an LED warning. A fair state would be whenever the score is between 50 to 69 with the LED continuously flashing. A poor state would be given whenever the score is lower than 50, giving a LED flashing at the same time with a buzzer beeping. Through the Sleep Quality Monitor project, I achieved several key course learning objectives. I applied soft computing skills like debugging and unit testing. I created 3 unit test files with the try-catch blocks and debugged issues like the inverted light sensor calibration. I demonstrated programming fundamentals by using variables for the sensor data, if statements for alerts, and a switch statement for sensor validation, and a while loop for a continuous monitoring, and the kill switch button. All 3 functions include proper documentation. I used MATLAB to implement a real-world application. The system converts raw sensor voltages into a meaningful units using calibration formulas, then calculates a weighted score to evaluate the sleep quality. Thank you for watching.